To solve this integral, first of all, I need to substitute with minus 4x in the third power plus 2 as u, which it means that the derivative of u, it would be equal, du is equal with minus 12x in the second d of x. Since we have only x in the second d of x, for this reason, I need to write x second d of x. I'll divide both sides by negative 12, which it means that they cancel out and I have x squared d of x. It would be equal with minus 1 over 12 d of u. Which it means that our integral it would be equal with minus 1 over 12, the integral of e in the power of u du. This integral it would be equal minus 1 over 12 e in the power of u plus constants. For this reason, our integral it would be minus 1 over 12 e in the power of minus 4x in the third plus 2 plus constants. Let's continue with another type of the integral. Again, I have e in the power of something times x in the second power d of x. In fact, this part that I have in denominator, which it is minus 3 over 2x in the third power plus 1, I need to substitute with u. And we can find the derivative of u, it would be equal with minus 3 over 2 times the derivative of x in the third power is 3x in the second, which it means d of x. That we have du, it would be equal minus 9 over 2x in the second power d of x. In fact, I need to have only x in the second power d of x. For this reason, I need to write in that form. Since I have multiplication, when it goes another side, it goes as division. And we have du divided by minus 9 over 2, it would be equal x in the second power d of x. In fact, this one we can write as multiplication. We flip our fraction, which is 2 over minus 9 or minus 2 over 9 du. It would be equal just x in the second power d of x. For this reason, our integral, it would be equal with integral of e in the power of u times du is x in the second power dx. For us, it is minus 2 over 9 d of u. For this reason, this integral it would be equal minus 2 over 9 e in the power of u plus constants, which it means that is equal with minus 2 over 9 e in the power of u. For us, it's minus 3 over 2x in the third power plus 1 plus constants. Let's continue with another type of the integral. If we have, for example, the integral of e in the power of minus 5x plus 2 over 3, we can substitute with u, it's equal minus 5x plus 2 over 3, and the derivative of u, it would be equal with minus 5 over 3 dx. But I have only the dx. For this reason, we multiply both sides by 3, they cancel out, and we have minus 5 d of x, it would be equal with 3 du. I'll divide both sides by negative 5, which means that we have dx, it would be equal with minus 3 over 5 d of u. For this reason, this integral it would be equal with the integral of e in the power of u times dx. For us, it's minus 3 over 5 du. For this reason, we can write as minus 3 over 5 e in the power of u plus constants. For this reason, our integral it would be minus 3 over 5 e in the power of u. For us, it was minus 5x plus 2 over 3 plus constants. Let's continue with another type of the integral. We have x squared plus 6x. Again, I need to substitute with u. And the derivative of u for us, it would be equal with 2x plus 6. All of these dx. In fact, I have 2x plus 6. This one, 2x plus 6 dx, I can write as du. And we have the integral of sinus x squared plus 6x, we wrote it as u, sinus of u, du, because 2x plus 6 dx is just du. And for this reason, this integral, it's minus cosinus of u plus constants. Now we substitute with u with 2x plus x squared plus 6x, and we have minus cosinus of x squared plus 6x plus constants. Thank you. Please do not forget to leave the comment below for what type of exercise you are interested, and don't forget to subscribe my channel in order to motivate me and to provide more videos for you. Thank you so much.